Hello everybody, this is expanded synthetic division. As you know, if you have a polynomial in the numerator and a simple x minus 2 or x plus 5 as the divisor, you could write down all the coefficients, and in the pocket you would negate this negative 2 into a positive 2 and just do synthetic division. Otherwise you have to do the long division. Well, when I was in college, I was reintroduced to synthetic division, and I thought, well, was there an easier way to do synthetic division even if it was not something like x minus 2? Something like this. Is it possible to use synthetic division like this and not have to do the long division? Well, I have proved at least one professor and 2 tutors wrong that it is possible, and I'm sure there's just a handful of people who know about this, and I just thought, I can't really find it on YouTube, a tutorial, and I only found it just one place on the internet, so I thought, why not? So as you would know, regularly you would write down all the coefficients in the numerator. So you have 8, 2, negative 4. Now remember that you have an x1 here, so the coefficient in front of x1 has to be 0, because 0 multiplied to anything is 0, and that's why it's not written. So you have to remember to add that 0 in there, and then this 10 does not have, well, this 10 is 10x to the 0, and x to the 0 is 1, multiplied to 10 is itself, so you put 10 here. And a way to check is you take the power of this the degree of the polynomial 4, you add 1, which is 5, and you should have 5 numbers here, and you do. So what I would do then is just go ahead and set this up first. Draw a long line, and then a line this way, and then since you have 3 terms here, try to leave like 2 rows here and 2 rows here. So you take the first 2 right here, or whatever this coefficient is, and you put /2, and I'll get to that in a couple of moments. And then what you want to do is take all the rest of the terms, 4x minus 2, negate them like you would in synthetic division that you're familiar with, and put minus 4 right here and 2 right here. Okay? And then what you would do is you would bring down this 8 and write it right here like in regular synthetic division. Now this 2 right here is going to be a 4, because 8 divided by 2 is 4. Now you're going to take the 4 and multiply it by this negative 4 here, which will give you negative 16. And I like writing it in a diagonal like this because it will help remind you that when you take 4 and multiply it to 2, you're going to get 8 right here, and you put it in this column and not that column. So that's how I prefer it. You want to then take 2 and subtract it by 16 to get minus 14. And then you take minus 14, divide by 2, and you get negative 7. And it's just that simple. Take negative 7 divided by, or multiply it to negative 4, which would be a positive 28. And take negative 7, multiply it to 2, and you get a negative 14. So you take, just like regular, minus 4 plus 8 plus 28, which is 32. Take 32, divide that by 2, and you get 16. Now, you take 16, multiply it to negative 4, and you get negative 64. And again, 16 times positive 2, you get 32. Now, you take negative 14 added to negative 64, and you should get negative 78x. Now, before you go any further, let's imagine if we divided this by negative 2, by 2, and you'll get negative 39. And you take negative 39, multiply it by 4, you put that here, and the product here, and then you'll take it negative 19 to 2, and then you'll get 38 here. This will go off course. It will like fall off the cliff here. So that should tell you to stop right there. And that's when you want to draw your vertical dashed line here. And you'll just take 10, add it to 32 to get 42. And I actually went ahead a little bit. And that's all there is to it. So this would be the remainder, and you don't divide by 2. Now, if this was 3x squared, then it would be 3. If it was 9x squared, then it would be 9 here. And I'll probably do one more with large and make it larger, so it could prove that anything is possible. So next is oh, and also one more trick that I use. Take this, the degree of the polynomial in the divisor, which is 2, and start back here and go 1, 2, and then draw your line here, and this is the remainder. That's another trick you could use. And again, I know that you could factor out the 2 here, but for simplicity and to make this easier, I just made them all divisible by 2, or multiples of 2 here. So now you want to add in your x's, so this will be x to the 0, which is 1, so you don't have to write that. Same thing here. And you have an x here and an x squared here. And if you had one more, it would be x cubed, and then x to the 4th, and so on. Now you have this. Now what do? Well, you just write it out. 4x squared minus 7x plus 16 plus, then the remainder, negative 78x plus 42 over the original divisor, 2x squared plus 4x minus 2. And that is the answer. And right on time, 7 p.m. where I am. Alright, so this is expanded synthetic division. Thank you, everyone. I'm not going to ask you to like or subscribe. I am passionately doing these videos from my heart. I am not calling any of my videos perfect or ideal, relatively speaking. Besides, this is merely a fraction of a 0.25% of all the myriad of videos out there concerning the subject, including videos with more easy to understand animation and explanation. I am simply one voice out of many.